So any container that you already have or you might want to create, you can basically refer to those from here. Remote container, remote repositories is when you connect to your account. So you can just sign in and connect to your Docker Hub account, and there you might have your repositories readily available. Image, basically image is nothing but a software that we want to use. All right, so just follow these steps, friends. And yeah, let me know if you have any challenges. Right, and these are the system requirements. By default, you will have these softwares. If you don't have, then you might want to install this. Windows 2, right? Backend requirement. If you don't have, then yeah, you can just download and install this application. If you want to use Hyper-V backend, then these are the steps. Any one of these options can be chosen, friends. You don't have to restrict yourself to use one of any one of that, but yeah, you can just basically use one of these. I remember I have installed sometime back. Yeah, I just followed these instructions. Yeah. Same folders. Let me know if you are having any issues in installation. So to start with, as I said, download this .exe file. Right, when you click on this option, download Docker Desktop for Windows, you'll be able to get to work with .exe file. Double click that, and you will see all this. Let me see if I have this already. And I don't have this. Yeah, so this is image.exe file. I'll just click on this. It's already installed in my computer. I'm just showing you how the interface looks like. So my version is a little older version because I've installed it some time back. It says, do you want to replace it? Right, so I'll say no, at this stage, I don't want to do the installation. But when you do it, it goes into the UI, and then from there, you can just follow the steps. Anybody is doing, if you want to share your screen. Is anyone installing or already installed?
I think I'll try later.
Okay. No, it's just that I wanted to ensure that the recording is done because my installation is already done. I cannot share the steps. So if anybody is doing right now, we can share your screen and record the steps. From that perspective, I was asking. Okay, fine. So I'll assume that you have installed, and right, let us try and run some steps on Docker. Docker has cheat sheets. You can also get those cheat sheets directly from the website. But these cheat sheets are already shared with you. This is the cheat sheet. These are all the commands, right? Typically, we will do this. Build your application image, build an image using the Docker file. Right? You will have to go to the current folder, and then you have to have all these files ready, and then you have to build your Docker image. Then if you want to share, right, image, you can basically push the image to the repository. That is Docker Hub, right? So it goes and sits on your Docker Hub in your account if you want to push it. If you want to use something which is already there, you have to say pull. Build is to construct your local Docker image right now. And then once the Docker image is created, or once the Docker image is available, in order to create a working environment, you will have to say run. Docker container run. Runtime instance will be created. And so these are high level 3 steps that you will have in Docker. So let us try and check that. These commands are also given. Is this example? Yeah, this is one of the example which is already shared. I think Docker commands would be there somewhere. Okay, fine, no problem. We will try and run these steps. So I'll go here and I'll say Docker. Because Docker is already installed on my system, when you say Docker, it gives me the instructions, right? This is like basically you're doing a wrong command and it is like help. If you want to specifically know the information about any specific command, here you can do this. Docker, that command, help. Okay, or you can just type this. Right, like this. Just replace your command with whatever the command that you want to run. All right. So this is basically the syntax. You just say Docker and then command. Okay. All right. Docker space images. This will list out the images if there are any. So if I go here, we will see the definition. Images, yeah. So Docker images. So Docker space command. This will list out all the images, and for containers, we have something called as PS. Yeah, list containers. Pull and push are there. These are basically to pull and push the commands, the Docker images from your repository. And for this, you'll have to, of course, log in. You can just say login, Docker login, and you'll be able to connect to your repository. You need to give your username and password on the command prompt to connect. This is to build the image. We'll run this now. And we'll try to construct an image. Okay, let's see if I have that basic Docker creation steps. Okay, it doesn't have basic steps. I think I do have something here. Do I have something here? These are also Fine. So we will try and pull one image which is available here on the screen. Yeah, so these are the images. See, very simple steps. So we will basically try to pull one image directly from the public repository. So if I want to see what is this, you might want to go to the hub, Docker hub, and search for Ubuntu. Ubuntu is a Linux operating system, right? And we are creating an image for your Ubuntu. So Ubuntu is a Debian-based Linux operating system, open source basically. So if you go into that, this is the repository, and we are trying to set up a Docker image using this Docker pull Ubuntu command. Right, that's the command you have basically seen here. Latest is basically the tag name, or you can say version name, repository, and the application. Okay, so I'll just copy and paste it this. You know, if you don't want to use that colon latest, that is your choice. And what it does is it basically takes the image, right? It is total size of 30.43 MB in your repository. It is downloading that image, this particular image, right? We have these different documentations. You can try and read that. So you'll have a software which is put here, and we are trying to download the software onto my local machine, right? That's all. It's basically doing that. So Docker is layer application that you have developed or somebody else has developed, and we are trying to set up that Docker image on our local machine. Yeah, it's done already. Okay, so newer image from this particular location we have created. This is the location basically, right? So if I again say Docker images, so here when I did Docker images, it was not showing anything. Here I will say Docker images again. Now you can see this is the repository and the tag name is latest. This is the image ID, and this has been created just now. Created is 2 weeks ago because probably, right, I might have used the same image previously some time back. All right, so that's recorded in my system. So it's basically showing 2 weeks ago. Okay, so this is your official image, and these are the various tags. So you basically see the tag, and you can see this is something which is pushed 15 days ago. And some updates have been happened recently. So that is also something which is basically shown. All right. Now this is a Docker image. You can come here in the desktop, and you can see under the images, the image that we just have created is shown. Okay, and you can see created 15 days ago. Right, so that's basically how we can create an image. Now this image is not active. I mean, it's not running, right? We did not create a runtime instance from this image. So we will be able to create that runtime image as well. So all you have to do is run. Either you click on this run, and when you do that, it creates a container here. Right now, we don't see any container, right? But when you do this, a container instance will be created, or we'll stick to this right command line interface to run the instance. So you can see this is the basically the command to create a runtime instance of your image that we are using, right? So either you can use the front end or back end. So if I click on this, these are the various options that you have. You can give a container name, right? You can also give the host volumes and the environment names to basically give. Or I'll just, as I said, I'll use this default option, container run. right? And create my Ubuntu instance here. I'll say Docker run. What is the tag? Run a command in a new container. Okay. Okay, let me see the shortcut. Here, Docker container run. You give the name. Let me first start with this. I forgot. So I'll say Docker PS. When you say Docker PS, it lists out the containers which are running. List the containers. I don't have any container right now. Right, so we'll have to try and create a container, right? So let us do that. And as you have seen, we have to basically say Docker run, and then we need to run the Docker. You can basically give the port numbers and all that. I'll just simply use this command and I'll try to run the Docker image. Okay. So you have to remember the, sorry, it did not copy. I'll just type it. Docker run -p. Yeah, -p. That's the port number. And I'm exposing that to, let's say, 5000:5000. You can put any port number. And what is the image that I have? Ubuntu. You can also put in. Where is it coming with this? Good. I'm running the instance. Strange. Why is it not running? Let me just check. Why is it not running? No, this one do I have? Yeah, this example is already there. But this is for a machine learning. Why is this Ubuntu not working? Let me just run this without port number. Docker container run options image. Yeah. If I go to the official documentation, this is the pull of image. We have pulled the image and we have all these updates here. Strange. This is what we have done. This is to pull the latest of the image. What does cheat sheet say? Container from Alpine version image and running the container web exposing port number 5000 map port 80. And this is the run. This is what we have done, right? Let's copy this Docker container run, I'm saying hyphen name, right? I'll use the same name, hyphen p, exposing this, let's say 80 only. Image name is Ubuntu, tag is latest. Why is it not running? Let's use the front end and see if it works. Okay, I'll just run it without any name. Oh, it's already running, but it is not able to start, is it? Let's start this. There seems to be some issue in the image. This is what we have recently run. Okay. So the containers are starting, but because of some reason, it is not able to stay. This is what we have recently done from the command prompt. This is basically what we have done. It says in use. And these are the services which are used. Fine. So we'll not waste our time here. We'll move on. We'll try and deploy one of the local machine learning model that we have, and then see how does it work. Okay. In the last session, we have discussed about one of the machine learning model that we already have. Right. So let us try and look into that. This is the Docker. This is the image. And this is my repositories. So this is a repository that I already have, right? And I don't have any image updated into this. I can also push my image. I'll try to show you that, right? And then we will see how we can use that image in deploying, right, for usage, right? End user usage perspective. So for that, I need to go to model. This is our machine learning model, right? This is basically the right Docker image. Okay. Whenever we try to work with the Docker images, the mandatory things that we need to have is the requirements file. Let me open the requirements file here. You can see in this particular application, I'm basically just added all the Python libraries that I probably will be using. I mean, I just pushed everything which are required. If your application is a very small application, you don't need so many dependencies. But these are all the libraries that you need to have for your application to run without any issue. Okay, so this is the requirements.txt. We keep updating that. Then we have this Docker image, a Docker file, which contains the instructions for your Docker application to work. So you will have the right command. We are basically saying from Python, that is the version 3.8 version is what I want to use. And I'm exposing this application at port 80. Expose this application to port 80. The working directory, you can give any working directory. Remember, a container has Linux operating systems. So under the current working directory, the home directory, we are creating a folder. So you'll basically have /home / the user name, whatever the name that you want to have. This is where is your working directory. Under this, we are trying to have a folder called Flask-Docker. You can give any name, your choice. And once this folder is created, we are instructing the Docker image to copy the required files. Requirements.txt. So we are first doing the copy. And then we are ensuring that the environment is updated. So we are running that script requirements.txt, which will ensure that all the libraries that are required are updated in our environment. Then we are copying everything from this folder to the Flask drive, right? Copy.
Hey, Sharad, question. So,
yes.
Which one is the image here?
Image? No, we are creating an image. We have not created an image. We are going to create an image using the script.
Okay.
See, there are, okay, let me explain the files here. So when you talk about machine learning model, you're probably developing your code using .py or .ipynb. This is your Python script or notebook. This is where your ML code resides. In our case, this is the file. Here, I'm having a multiple linear regression. I think I've discussed this code, right, already in my previous sessions. Also, I've shown you where we are trying to predict the fuel efficiency, right, mileage of a car. Some sample machine learning code we are using. It could be any code. It could be a machine learning code. It could be a deep learning code, whatever it is. This is your ML code. Now, when you run this code, you will have a pipeline implementation. Always remember, pipeline implementation is mandatory for productionizing your machine learning algorithm, right? So using pipelines, we will save the best model, right? This best model is saved using either pickle or joblib files. Okay. These are the Python libraries. So when you do that, you get pickle file, and this is the data pre-processing file. If you remember the code which we discussed in our previous sessions, we had data pre-processing pipeline. I'm calling that as column 1. And this is the best model that we have trained. So these are important. This code is not important for us. These are important. Okay. And in order to use these saved models using a web UI, here we are using Flask application. Okay. That Flask application is here, app.py. This code is also required. So I'm using 1, 2, 3. These 3 are from your ML model perspective, right? Pipelines, saved pipelines, data pre-processing pipeline, and the best model. You both these both can also be saved into a single pipeline also. That's basically from an ML model development perspective. In our case, I have 2 different pipelines, and then I have Flask application code. Right? I'll show you what exactly happens here in the Flask application code also. I'm saving it in the notepad, sharing it in the notepad. So we are importing Flask and the rendered template application, and we are creating an app here. You can just put this app somewhere here also. Okay, like this. This is our application. Okay, you can put this here as well. So these are basic Python requirements. We are importing the libraries, and we are importing the saved models, loading them into the environment. And then this SQL Alchemy is to ensure that we connect with the database. Here I'm commenting it. I'm not using this database connectivity thing. I just commented that. And then we have the Flask application initiated. This is the initialization. Instantiation happens here. And when you are trying to connect with this application, by default, it goes to the /. So it's like your website, right? So your website will have host:/port. This is the address, and you'll have /. This is the home directory or home page for your portal, web UI. So when you're coming to this location, this is the landing page, you are basically saying render this template and give the experience to that particular end user. So we are defining a function called home, and this basically is calling the function, returning the rendered template, and this HTML document has to be executed. That HTML document is also there here itself. Always in Flask, we use the standard folder names. Templates is the standard folder name inside which we need to have the HTML page. So again, I'll show you the HTML document here. It's a simple HTML document. We'll have mileage prediction, right? Basically some kind of a text, logos and all that. And this is where we are passing the input. So input type is a file. We are passing a file to be loaded. And once the file is loaded and once the action is happening, submit button is created. It goes back. It returns back to the submit page. So if I go to again this file, here when we do the action, it goes to the /success page. So when you come to the /success, we are triggering this particular function. So in success, it takes the details of the input file that is getting passed, uploaded, right? And we're converting that into a NumPy object and then doing the data processing. CT is the data processing pipeline. So I'm transforming the data using the CT. And then I'm doing the predict using the model that we have uploaded here. This is a trained model, right? So using the trained model, we are predicting. We get the results, which are converted into a data frame. And this data, this is basically getting added to the original data itself, right? And we are basically printing that result. Okay, so that's all we are doing. These lines are commented. These are used when you want to push the results into a database, right? So I've commented the database details, so I'm not connecting to the database. Hence, I'm not pushing anything to the database. These lines are commented, right? So that's basically how your application runs. I'll not say anything. I'll just come out of this, right? So now for Docker image to be created, I will take this, and this. This code is not required. Remaining everything is required. From an ML model perspective, we need the pipelines, right? These are ML model related files. Then from Docker perspective, oh, sorry, this is also from a deployment perspective, right? Web UI perspective. I'll change the color so that you understand. Web UI perspective, I will take templates folder and app.py. These two will work always together because Web UI will need these saved models. Then from a Docker perspective, I need the Docker file, Docker script, and the requirements file to ensure that the dependencies are updated. Right, so these are the three set of objects that we are using. So the Docker will take these files using the dependency files. It will first set up the environment and then puts these content into that environment. This will give us an image which can be run in any server, anywhere, right? I mean, any computer, basically. All you need to have is the Docker software. That's all. Right? So this is basically the deployment stage. To deploy, we are basically giving these instructions. So command is using Python 3. You want to run the Flask application and right, host it onto the local machine. 0000 is your local machine. So when you do this, this is basically like the edge point. We are creating the endpoint here. So what is happening? From Python, where we are basically trying to use this Python image on the Docker image, where we are exposing the content onto the port 80. We are creating a folder called Flask Docker. First, we are copying the requirements file and ensuring that all those dependencies are installed, and then copying everything into that folder. Once everything is copied, then we are executing this to ensure that the image is getting executed. Image is nothing but ML model, right? And that script gets executed here, and we get the end outcome, right? So this is your script which gets executed at the end. All right. So in order to do this execution, always ensure that we go into the directory where this file is. Okay. First, we'll have to go into the directory. So I'll say D:, and then I'll say CD, copy the path and give it. So you can see these are our files, right? I will show you what exactly happens on the end user perspective. If you run this machine learning code on my local machine, then what is happening? So I'm first running it on my local machine. In order to execute this Flask application, we basically say Python app.py. That's all. Why? Install Flask. It basically says that my local machine does not have Flask application installed. That's the reason I had to install Python Flask application first. Yeah. See, once you execute it, it basically creates the runtime environment, and we are getting the host. So I'll use this quote. And this is the web UI that we are seeing. And I will just open. Go to the location where I have this test file. I don't have the test file here. Very good. Yeah, I have the test file here. I just select it and then submit. So this mileage is the output, predicted output using machine learning model. Right? So this is how the end user will see. Right? You can see here, this is slash. And when I click on submit by passing this data, in the backend, the action is getting triggered and predict function is getting executed because it is redirecting to slash success page. And in the success page, these output is getting printed. This is on my local machine, right? So I'll just cancel this. I'll close this and I'll come out. Okay. Now, in the Docker, I'll be running this. So first, I will have to create an image, right? Build function has to be used. Where is this build function? Let me use the commands file where I have. Yeah, this is the build function. Okay, so build the image. So for building the image, this is what you have to say. I'll change this name anyways. I'll say Docker build -t. I'll say MLR cars v1. I'm tagging our image is v1. The repository name is this. I'll say v1 directly. Yeah. So dot is where my location is. So my image name is MLR cars v1. The content is in my current location, and I'm trying to build this image. So Docker build -t image name dot is the current location where I have all these files. So you can see it's basically copying everything, setting up everything, right? pip3, this command is getting executed now. All the copying has happened. It's taking time to build all these requirements that we have, right? These are all the applications that is getting incorporated. Exporting the images and done. So image is created. This is in my local again. So I'll say Docker images. You will see Docker images created. Now look at the size of my application. Because it has model, it has saved trained model, it has Python application installed with all the updates, right? So it basically has 615 MB file. So you can basically try and check all this. Storage space. So if you look at the files, individual files, this is only how much? 86.5. But when you are implementing it onto the Docker, all the runtime instances are getting executed. Python software is executed. These libraries are executed. So total size is 615 MB. Right? Now, this Docker image that we have created is on our local machine. Okay. Unused. This is not used yet. Okay. Now I want to push this onto Docker Hub. Okay, I'll do that. Probably first we'll try and execute it so that it is creating a runtime instance and we are using it. Okay, so to push this onto our page, we need to log in and then we'll just use this command Docker push. And to run the Docker image, I'm basically using this command. So Docker run -p, you can see that command is also given here. Like this. Build is done, right? And in order to run this, we are going to use this port number and the Docker image. So what is the image name? MLR cars v1. This is the image name you can see. So when I run this, the Docker image is getting containerized now. Runtime instance is getting created and we are exposing that to port number 5000 only. 5000 to 5000, I'm mapping the port numbers. Done? Okay, great. I have these warning messages. Hopefully it doesn't impact, but let's see. Yeah, I'll take this. This is on the local host. I'll open and I'll run this and you get this image. Right? So that's basically how you can run your application. I can also try and check. This is a different host name 172 now. And hopefully it works on this as well. It's not running on this because internally the mapping is not done. Fine. So on local instance, it is running, right? So this is basically the application URL that we are using. All right. So we'll cancel this. We'll create another command. Docker images. These are the two images. Docker PS. It will talk about the container which is running. Right. So local host, port number 5000, and we are exposing it to 5000 port number. Right. So that's basically your Docker containers. So you can basically try and push this image onto your repository. So when I say Docker login, it is asking us to log into the Docker Hub using our credentials. And this is the URL. So I'm just going to use my, I don't remember my password, but let me try. error response, incorrect username and password. That's the problem. Oh, okay. Let me do one thing. I'll try to connect it from here. I don't remember my username password. Unfortunately, yeah, this is my username, correct? I don't remember my password in that case. Okay, fine. Thanks to the desktop, I'm able to now log in. So if I say login now, it will not throw any error. Docker login. It will say you authenticated. Login in your terminal, access to your account. So we are login succeeded basically. Now I want to push the image that I have here, Docker images. I have this MLR cars V. This is in my local machine, right? I don't have this on my repository here, right? So I want to push my image here, right? So let us try and do that. So this is my repositories. I don't have anything. You can create a repository like this and right, try to use this repository. But I'm canceling it. I already have one repository. Let us use that repository itself. So I'll use this command. I'll push this. This is my repository. And the image name that I want to push. Image is this. That's all. Image does not exist. Oh, I have not logged in first to create the image. Okay, very good. And yeah, so it's now getting pushed into a new repository altogether. Request access is denied. Okay. You understood the problem, friends, here? The Docker image I created was created without logging into the repository. I did not log into the account, right? So this is an image which has nothing to do with the repository that I have created on my Docker Hub. My repository is this, right? 360DigiTMG. This is my repository. So what I'll have to do is I'll have to first create the Docker image using that repository first. So for that, let me just recreate the command. I'll just run this once again so that I have the repository name mapped. Right, so I'll just run this, but this will not work out because I'm not in that location. I will go to that location and I'm just recreating the image once again. That's all. See, this is my repository. Okay. Here, the repository is this. Image ID is this. So image ID is same, as you can see, but this time I have the repository name mapped to the repository name that I have in my Docker Hub. Right? That mapping needs to be done. Now I'm pushing this app image onto my online repository. So Docker push this image that I have. Now you're able to see that the image is getting pushed into that particular repository. So here in image, you will be able to see this repository once it is getting uploaded. So 615 MB content is getting pushed from my local machine onto the Docker Hub. Let it finish, we'll be able to see that. Now, if I don't push it onto my Docker Hub, the image is not accessible from different locations because the image is only sitting in my local computer. I can create as many containers as possible using my local image only in my local computer. But now, because I have pushed this image onto the Docker Hub, I can connect to Docker Hub from any different computer, and I will be able to implement the image and create a container on that different systems as well. So for example, I will give you the access. I'll make the image that I'm putting in Docker Hub. I'm going to give you the access to that particular image, for example, right? I'm giving you the access, or I'm making it public. So you will be able to log into your Docker account. And because you will be able to access this public image, you will be able to run the same container run image function that I am doing. And the image will be implemented in your machine as well. So the image that I created is used by you, and you will be able to run the machine learning model on your machine. Right? So that's basically how the Docker Hub actually helps in creating the applications. So this is pushed. The entire application is pushed. Now let us look into this image. I don't have the image. Yep, look at that. This is the image that I have created just now. Right? Few seconds ago, I have created this latest image, and it runs on the Linux operating system. The compressed file is 250 MB. That's basically shown here. You can see that, right? 2205 is the size. Okay, this is the entire content that we have pushed. These are the image layers. Okay, so you'll have bash, that is your OS level thing. Python version is 3.8.16. That's what we have set up. And by default, pip version is also installed. And using pip3, we are trying to set up everything here after copying the file. And then we are again copying everything after setting up the environment. 209 MB is what is getting installed. And then once this is done, we are executing the function. Right? Now, if you see here, I already have a container set up, right? So you can also access this and create your front end like this, right? So this is the image. Using this image, you can try and install it, and then you can try and run the machine learning model. This is how the Docker image and Docker containers are useful. I'll just delete the Linux images that we have used in previous cases. I'm just deleting this, not required. I'm also deleting this. I'm only keeping one image. This is in use. I'll just delete this. Looks like this is fine. So you can see Docker images. I'll have only one image now because the other things are deleted from the front end. And if you say Docker, yes, this is one container which is up and running. All right, this is in my local machine. The same image is being pushed onto the Docker Hub as well. So in our next class, that is tomorrow, I will be showing how we will be using this Docker image, which is pushed into the Docker Hub, right? And I will try and use GCP instance altogether. So you can see this is specifically designed for that. So on GCP instance, I will be using Kubernetes engine, that service, register or basically create a cluster, use Docker account, log into Docker, my Docker account on the GCP, and then try to access this particular image and deploy this application on GCP service, on Kubernetes engine, right? So we'll try to do that in tomorrow's class. Yeah, any questions today in this part?
Yeah, sure. As far as I understood, basically Kubernetes is just like an orchestration tool like MLflow and
Yes,
Airflow.
that's right. Absolutely. And it is also having the special tag. I mean, it is created so that we can maintain multiple containers if required, right? Auto scaling is one of the primary features that Kubernetes engine has.
Okay.
Yeah. Any other
Uh,
questions?
Sharath, I have a generic question. So we discussed deploying a model on SageMaker, right? So
Yes.
is there any other way in AWS where we can still deploy models without using those kind of end-to-end platforms like SageMaker?
Did I not cover the setup of locally? I mean, we also did that, right? We have not used SageMaker completely. We used Notebook, and whatever the trained model that we have in our local machine, we use that trained model on XGBoost is what something we have done, right? Remember, on Notebook instance we used, and then we deployed the Notebook instance, machine learning model using that. We have
Yes,
not
yes.
used end-to-end SageMaker autopilot.
Okay.
So there are basically two things that we use. Where is my Epic pen? Let me open that. Sorry. Okay, I'll just use this. So when we started, we used autopilot, which is an auto ML feature in AWS. And this service is basically called as SageMaker service, which is specifically used for machine learning model development, maintenance, building, right? All those things. So autopilot is one service, but we also used notebook instances. Notebook instance is basically a Python environment, a virtual machine, which is created only for Jupyter Notebook environment. So we created an instance. We took this Jupyter Notebook instance, loaded a locally trained model, right? When I say locally trained model, we have also used the code or the saved model, the image, saved
When
image.
you say notebook, this is Jupyter Notebook, right?
Yeah, it was giving us Jupyter Notebook page, right?
And that we have taken from SageMaker itself, right?
SageMaker is just a service.
Okay.
Under which we have taken only Python instance, I mean Jupyter instance. That's all. We have not taken autopilot service.
Okay.
So it's like we are taking one virtual machine. Under that virtual machine, we have Python installed and Jupyter installed. So we are only taking this. And this is basically available under SageMaker. Because SageMaker is like a service which allows you to use multiple resources which are interconnected. So we can call required services directly from this Python environment for deployment. Ultimately, you need machines, right? So that can be done using the SageMaker as a complete service. See, if you are saying, no, I don't want to use SageMaker service completely, then we can do the same thing by using only virtual machines. So you'll have to bring in a standalone virtual machine. Then
Which is like
in
an
this
EC2
standalone
instance.
machine, sorry?
Is it on the EC2 instance?
Yes, when I say VM, it is EC2 instance. This is also EC2 instance only.
Okay.
But in this EC2 instance, the software is readily available to you. Because we are only interested in Python software here, right? So that's the reason why we get only Python Jupyter Notebook instances readily available in the EC2 instance. None of the other services are used here. So billing will be only for that perspective. So if you use EC2 instance, standalone EC2 instance for creating a virtual machine, then you will have to install Python. You will have to install all the dependencies. And then you will have to probably load or copy paste the data and the code onto that EC2 instance, then execute your entire. So this is a manual effort. But again, if you want to deploy it, you'll have to probably take a different EC2 instance, put the saved model, the Flask code, all those things have to be moved here. And then you have to ensure that the service is up and running always. This EC2 is exposed to the external environment. Right? So this is basically like whatever you do on your local machine, you're doing on EC2 instances. So the network handling, these dependencies handling, and all those things will be external work for you, additional work for you, which is automatically taken care of if you use SageMaker. Here also you're doing manually only. But with respect to the maintenance, dependencies, and all those things, a lot of work is readily available for us. Autopilot is like completely automated. Everything is automated. Right? So these are the three different scenarios. This is something we will not be able to do it very easily. You need to have a lot of network related knowledge. Right? You have to be very thorough with your entire ML services, I mean, your cloud services and all that. This is for data scientists. This is for probably more matured and cloud practitioners. Software developers, you can say. Okay, use the cloud services.
Okay.
Right. Any other questions with respect to Kubernetes or anything that we discussed till now? Okay. So what about tomorrow? I just wanted to ensure that we have some understanding on what exactly has to happen tomorrow. Yeah, any more further questions with respect to the subject that we discussed till now? Okay, I'll ask you more questions. So let me stop the recording.